Okay, so a couple questions here. One is about the Nexus 2000. Is Nexus 2K capable of both 1 gig and 10 gig? Yes, it is. Okay, so it depends on the specific model. The one that we are going to be using, actually the two that we're going to be using, which are the 9348 and the 2348 and the 2232, these support both 1 gig and 10 gig downstream. Okay, so host-facing interface, this is going to mean towards the server. This would be within the rack, southbound towards the server. Whereas there are some of the older ones, like the 2224, that is 24 ports of 100 gig, or excuse me, 100 meg and 1 gig. Okay, so it depends on the physical model, whether it's supporting 1 gig or 10 gig or both. There's a question, if there is a server 1 on Fabric Extender 1 and server 2 on Fabric Extender 2, can I create a port channel between them? You would not be channeling directly between the servers, but we will talk about the different supported designs with the extenders when we get to that individual section, which is one of the confusing things about how the hardware platforms work, about what is a supported topology and what is not a supported topology. It depends on what physical platform you're dealing with. So is the Fabric Extender connected to a 5K? Is it connected to a 7K? Is it connected to a 9K? That's going to determine how the Fabric Extender can do a port channel northbound to the parent switches, and then also it's going to control how it can do a port channel southbound to the servers. Again, whether we're doing a virtual port channel or not. So we'll diagram that out once we get to the extenders and talk about that in more detail. But main point being here is that they cannot make the decision on their own in order to do this traffic forwarding or in order to do the port channeling. You have to be connected to your parent switch. Okay, like we can see in this case, it says what can the parent switches be. In the current generation, basically any of the current switches you would use, the 5K, 6K, 7K, or the 9Ks. Okay, there's a question here, Nexus 1000V, is Nexus 1000V a virtual switch in itself, or it interacts with a virtual switch? So technically, the Nexus 1000V is a skin on the underlying vSwitch of the hypervisor. So it's not a replacement for VMware's vSwitch or KVM's vSwitch. It's an interface between us and the lower level API calls for us to make it look like it's a Nexus-based switch. But when you make a config change, like you say switch port access vThen 10, what it's really doing is making an API call to the underlying vSwitch and then programming whatever that software change is onto it. So in the current versions of the hypervisors, you don't necessarily need to use the Nexus 1000V. You can get a lot of the features without having to use it, but the main difference is that it's going to be from just the network administration point of view, it's going to look like a normal network device as opposed to a separate virtual switch that the server admins would be in charge of. Okay, there was a comment here, Nexus 6K also supports 100 gig now with the 6004 EF chassis. So the specific support for the chassis, of course, is changing over time, which within the scope of like the written exam, you do need to know some of the details about the hardware platforms. So I would recommend definitely to take a look at those links that I have put on here, which are the model comparisons. So if we look at, for example, like the Nexus 5K, you can see there's 10 gig platforms, and then there's also 40 gig platforms. And then in terms of the uplinks, you can see some of these have 100 gig uplinks if you're using an expansion module. So Nexus 6K is basically, or excuse me, Nexus 5600 is basically rebranded 6K. We'll see in our particular case, when you actually boot up the switch, the Raman on the back end says Nexus 6000, or like if you show version, it says Nexus 6000, but it's 56, from a part number point of view, it's 5600. Specifically, it's going to be 5672 UP, which is a You can see it's one rack unit fixed format, so it's not a modular switch, has 48 ports of 10 gig, and then it has 6 40 gig uplinks. But some of these are modular in terms of the expansion slots. So it's not modular in terms of like the different line cards you would see on a Nexus 7K or a 9500, but you can do different uplinks to the, not necessarily the parent switches, but like your core switches or your aggregation switches, depending on what particular modules that you plug in there. Okay, also there was a question on the Nexus 7000. In terms of the chassis, there are certain chassis variations that do not take multiple supervisors, which means that it makes them non-redundant. So if the CPU goes down or the line card goes down, then you won't be able to continue to forward traffic through that. Okay, within the scope of the Nexus 7K, if we go back to that same page, so let's go to cisco.com/go/nexus. And then from here, we're going to go down to products and services, Nexus portfolio, under Nexus 7000, and then compare models. Okay, from here, we see 4 different categories. So the supervisors, which is going to be what is the CPU, or basically the brains of the switch. We have the M series modules and the F series modules. These are going to be the ports that are actually forwarding traffic. Okay, like the new ones are the M3 cards that have, you can see on the 7700, 24 ports of 40 gig E or 12 ports of 100 gig. The F series modules, which the one we're going to be using is F348. But then also the different chassis variations, we have like a 7702, which 7702 only has 1 slot for the I/O module and only has 1 slot for the supervisor. Okay, so if that one module goes down, then you're not going to be able to forward any traffic. Okay, so this is the only one here that does not have supervisor redundancy, where the small 7000 would be the 7004. So it has 2 slots for supervisors, 2 slots for I/O modules, where the large one on the flip side is going to be 7018 or 7718, which is 2 slots for the CPUs and then 16 slots for line cards. So in terms of the capacity switch, these are going to be the biggest ones. You can see 83 terabits per second for 7718. It can have up to 768 ports of 10 gig or up to 192 ports of 100 gig as line rate. But this is the type of stuff that you may want to look at for the written exam. What are the specific differences between the platforms in terms of their hardware functionalities? Now, we'll see that once we get into the configuration, the commands that you would do on a 3K, 5K, 6K, 7K, 9K from an NXOS point of view are going to be identical. Just depends on behind the scenes, are we dealing with 10 gig Ethernet, 40 gig, 100 gig, and then in the case of the 9K, are we running in application-centric infrastructure mode? So are we managing everything from the APIC GUI, okay, or the APIC APIs, or are we doing it from the command line interface with the regular NXOS? So anything that we would do on a 5K, you could generally do it on the 9K with NXOS mode, but we'll see there are going to be things that you cannot do on 5K, 7K that you can do on the 9K when we're running in ACI mode. Okay, so if you guys have other questions, feel free to continue to type those in. Otherwise, we're going to take about a 15-minute break here, and then when we come back, we're going to get into our next technical section, which is going to be related to classical Ethernet switching on the, actually no, we're going to get into first the Nexus 7K virtual device contexts and talk about some of the hardware and software specific features of Nexus 7K. Then we're going to get into classical Ethernet switching, which is going to be traditional switching like you would see on your normal Catalyst enterprise level switches. So we'll start back here in about 15 minutes.